practical stuff for managers. I am not a manager, so I'm already kind of lying to you from the start. But I think this will be applicable. It's supposed to be a high-level talk. Really, what I want to get out of this is I want to kind of tell you from a very high level what big data is, what what the cloud is, and what it's not. Right? There's just so much misinformation out there. It's just very difficult to kind of get things. I don't know, to be accurate about and to not just spew nonsense. So hopefully I won't do too much of that. So this would be like I think my bio I like the most. So I'd like to tell you that I solve business problems and occasionally a computer is involved because I feel like that makes me sound a little cheeky. But basically I think like a lot of you is kind of a hybrid analyst, like doing a little bit of coding, not too much. If you just came in, please grab a chair. I'm sorry we didn't really put chairs out, so everyone who's here put chairs out. But I think for those of you who are in tech or interested in it, you may be similar to me in that you hear this story about I started here because I'm sorry, I work for IBM and I got started in tech, I would say, because I had a problem, right? So what's the story you normally hear about this, right? You hear from the programmers, they're like, it's kind of the same origin story, like, oh well, I was so lazy, I had this problem I had to solve, and I was just so lazy that I did all this really hard work and I learned how to code so that I could automate this problem, right? And from there it just spiraled, and now I have this lucrative career and I enjoy my work. And it was really just from this inner laziness, right? And this just really bothers me from the start because it's like, clearly you don't know any lazy people. Lazy people do not do a lot of intense work up front, like learning a programming language and writing programs, to then save time down the road. Lazy people are lazy now, and then they suffer the consequences down the road. But I think if you're like me, you might want to get into tech, or you got into tech because your problem was you weren't making enough money, and you realized that these other people were making a lot more. So if that's any of interest to anyone, I think this is kind of the right domain to be in. And I just want to establish that from the start, right? So we're here. I think you're spending some of your own time on whatever night of the week it is. You could be doing something else. I think you're here. I want to say that we're going to give you some information that I at least think will help you in a job interview. I hope you're able to get an extra few $1,000 from this, which is a huge claim, right? Fuck it, I think you can do this. So more particularly, right, why am I here? There's so much nonsense about big data in the cloud. It just makes it really hard to get started. These terms kind of mean everything to everyone. People will say things like, well, what big data means to me. And it's like, no, that's nonsense. Words have to have meaning. It has to mean something. It has to be relatively objective. It doesn't mean there can't be nuance. Doesn't mean there can't be ambiguity. But we have to kind of have a common basis from which we have these conversations. Otherwise, we're just doing it. And obviously, this really pisses me off. So I have a problem here. But I want to say, just because we may be ignorant, doesn't mean that our ignorance isn't dangerous, right? And what I mean by this is, I heard from, I can't remember your name already, but when you're talking to somebody like a data wrangler who's got billions of records of data and you want to be able to communicate intelligently to them, the fact that you're concerned about that is a huge positive. Because unfortunately, most of the managerial world, right, most of the suit and tie crowd is like, well, those code monkeys can be replaced soon. I'm gonna get somebody from another country to do it cheaper, etc. Like, they're not really doing the hard work. I'm doing the hard work. I have the strategy. I have the vision. I have my systems engineering V. That's the tough stuff. You guys are just implementing it, right? And there's this huge disconnect between the work that's happening, especially with these new technologies, and what the executives are thinking is going on. And we need to bridge that gap, right? We really need to bridge that gap. So this is hopefully a small step towards that. And I think from a kind of a pedagogical standpoint, we've confused, when we're talking about big data in the cloud, or tech in general, complexity and difficulty. So I would put it to you tonight that a task like running an ultramarathon is actually a very simple thing to do, but it's extremely difficult to accomplish. So in terms of technical complexity, one foot in front of the other for like 100 miles, right? You can figure that out. Can you actually do it? Totally different. But driving a car is actually kind of a complex technical skill. I mean, you have a lot of moving parts. You have to have knowledge of different systems. You're kind of reading in data from different places, right? In front of you, sides, behind, different hands, feet moving. But yet, most people are able to pick this up. So something can be technically complex but relatively easy to do. Meanwhile, something can be technically simple yet extremely difficult. So I have a point here, I promise. So I think that while big data in the cloud are complex, they're relatively simple to implement, right? That's what we feel. That's what we feel. we're just going to do this big data thing. I'm going to get Tableau and we're going to solve this problem. Right? That's all we need. Let's use the big data, right? Let's use the cloud. Everything's going to go well. So to them, like the concept, oh, I don't know if I totally get it, but implementation, no problem. No problem. So I posit right at the reverse. That instead, getting started with big data in the cloud or understanding the kind of the concept, I think is going to be relatively simple. That's what we're going to talk about tonight. And that's why I want to do this little hands-on demo at the end where we do this DS, load a website in the cloud really quickly, or play around with some big data or crunch some data with a big data tool set. Because I want to show you guys it's actually very accessible. It's not that hard to get started. But if you just at an enterprise level, you just say, hey, just go to the cloud. Now I'm going to transform our organization. It's extremely difficult. You start crunching massive amounts of data and totally change the way your company does business. It's really, really difficult. And to kind of to simplify that is to just throw it all under the umbrella of just go to the cloud and just pick up some good data is just vastly replacing the use of time. But you can get started right now. It isn't as hard to get going as I think many people think it is. People do. So I think it's going to be right. We'll do one right now. PySpark. Is it a big data processing engine or is it a new cigarette manufacturer? Any guesses? No guesses. Yeah, awesome. How about Kudu? Is that a storage layer for big data or is it a Pokemon character? Yeah. You know this thing is bad. I can't remember what the other one was. Oh, the last is Beanstalk. Is that from a fairy tale? I mean, this stuff is ridiculous, right? This is part of the problem, right? This is really part of the problem. Beanstalk, come on, like help us, right? Help us. And then at the end, if you want to stick around for this, I'm going to try to do this quickly. Invariably, every live demo will go wrong, but what we'll do is we're going to show you how to deploy a website, which is going to mean loading some static files to AWS. So if anybody has an AWS account, you can just throw up a basic HTML file, which I'll show you, and you'll have a website in like approximately 5 minutes. We'll also log into the only IBM product that I like called Data Scientist Workbench, which I think right now is, if you get anything out of this presentation, really, it should be, and I should have made this just like an entire slide. If you're interested in doing anything with data science, if you're interested in doing anything with analytics, if you want to play with data, go check out Data Scientist Workbench. It's the only cloud environment, and we'll talk about what that means. It's the only website you can go to where you can run Python and Spark and R, and you don't have to install anything, and it doesn't cost you any money. There's other services that let you do that, and they charge you like $250 a month for it. IBM has this product in beta stage right now, or whatever that means, so they're not charging yet. I can't promise that they won't start charging. Get in now, and you'll get grandfathered in for free. They certainly would charge me to use it, and I'm using it as much as I can. Any questions so far? I know I've rambled at you guys a lot. Okay. Oops. Big data. All right. So what is big data? Anyone want to throw out a guess? That's why you're here. Okay, so I posit that big data is data that you have to store and process on multiple computers. So this is in itself kind of a tough definition, right? The problem with our big data term is that it describes data, and what we're really talking about is software. What we're really talking about is the software that has enabled processing large amounts of data efficiently and cheaply. So what we're really talking about is a software project that has the stupidest name in the world called Kudu. So we're going to give you a quick little origin story on Kudu. So before 2004, if I wanted to crunch lots of data, and Dave, please interrupt at any time to correct wildly false assertions. But if you wanted to crunch large amounts of data, like you had 1 massive database of employee data that you're interested in. You're cross-referencing it with customers, et cetera, et cetera. That's kind of a ludicrous use case, but whatever. Let's go with it. As your data expanded, you would go to somebody like IBM or Oracle, and you would say, "Hey, I have more data than I can store in my than I can store in my database server. I need another one." And they'd say, "Great, fork over a bunch of money, and we will give you a new one. And you can rewrite a lot of the existing code that you had on that server. You can move all of your data over, and it's going to work great for you. And your queries are going to run fast, and you're going to be really happy." And then a couple years would go by, maybe 5 or 10. You're going to have outgrown that server. You'll call your salesperson back up, and you'll say, "Hey, I need another one," and they'll come and do the exact same thing again, right? And this worked pretty well from like maybe 1985 or so, the introduction of the relational database, rough 80s concept, till about the early 2000s. This was no big deal. But what happened like early 2000s, we get into this Web 2.0 world, and a bunch of web companies are now seeing this massive explosion of data. So if you've ever been to a presentation on big data, you've seen some ridiculous data chart, this line chart that just shows this like seemingly ad infinitum explosion of data, right? And it's like, data rates are expanding like crazy. Like, what are we going to do? Well, what these companies were doing is they're saying, "Crap, now I'm picking the phone up and I'm calling that sales guy again. But now I'm calling him a lot sooner, and I don't know what size I need to buy. I don't know how big of a database I'm going to have, how much data I'm going to be storing, because my rates are expanding so rapidly. So if I need to store this data, if it's part of my business to store this information, how do I forecast it? If I can't, now I'm spending lots of money on infrastructure, and this is a problem." Meanwhile, I have all these old servers lying around, not just the ones I've discarded, but others as I continue to upgrade my systems. And I see all these computers sitting here. Wouldn't it be nice if instead of having to buy a brand new big honking server every couple months, we'll say, I could use some of these existing servers, right? If I could string them together and use them as one, that would be great. It would save me some money, and it would scale a lot better. So what Google did was basically exactly that. They needed to index the web something on the order of every 15 minutes. So they had to come up with a way of processing all of those HTML files, what constitutes a web page. They were going to crank through each one of them. They needed to store them somewhere, and they needed to crawl them. So they could take that information and put it into their super secret Google PageRank algorithm. So they released a paper, and they explained how they did this. And they said, "You know what we did? Instead of buying these big, really expensive computers, we used a lot of cheap computers. And we built a storage layer, software, called the Google File System, so that we could store data on lots of computers. And since these are cheap computers, and there's lots of them, invariably one or two are going to fail all the time, like let's say on the order of every day. So we designed a system such that it's fault tolerant. If a server dies, we're okay. Now, we need a way to process data on this distributed architecture, where I have distributed architecture, lots of computers. They're all connected. How do I do that? They came up with a paradigm code called MapReduce, and that allowed them to process data in parallel. So we had the Google File System and MapReduce. They wrote like 2 5-page papers about this, and thanks to the brilliance of the software engineers of the world, specifically this guy named Doug Cutting, in circa 2004, some guys at Yahoo open sourced this. So they built this software project, the Hadoop file system and MapReduce, and they put it under the name of Hadoop. There's kind of a stupid story about how they picked the name of Hadoop, but it boils down to they just made it up, and the fact that people think it's funny kind of bothered me. But what this gave us, the important thing is what this gave us was it gave us the ability to process lots of data in a way that was kind of cost effective and that could scale. If I needed to process more data, if all of a sudden I have all this more information, I could grab a computer, I could throw it in my rack, and it would essentially just work. But it came with some costs, so we'll give you a little bit more about that. So this is Hadoop. You'll see charts like this, where it's we've got all this. It's like, I don't know if you guys can see this. All this data, XML, CSV, JSON, text, binary. It's flowing into this server architecture here. This is our cloud server, and then this relational database, and it goes out to this weird little spinning globe, which somehow is a symbol for business intelligence. We get that. We get this, which is probably a little better. If you can read this, it's like, there are these blocks. So this is HDFS here on the bottom, the Hadoop distributed file system where the data is stored. You see this thing called yarn MapReduce v2. What is that? There's this thing flume over here that's turned sideways, so I can't even read it. All this other stuff, pig, mahoot, R connectors. I don't think you need any of these. This is kind of what it looks like. I think you should picture this. This is code, Java. This is a MapReduce job in Java. It's ugly. It's nasty. But this is what you should think of when you look at Hadoop. So if a manager if as a manager when you think of Hadoop, you see this like very relatively pretty, but we'll say kind of complete picture of data flowing in and things just happening, right? Or you see this, which is more of an architecture that shows a structure. I really want you to think of this. This is what it looks like. Lots of Java code. Lots and lots of Java code. But what you need to know is HDFS and MapReduce. All the other stuff you saw on this diagram is superfluous. When you think of Hadoop, if you think HDFS, Hadoop Distributed File System, I have data stored on lots of computers. MapReduce, how I process data that is stored on lots of computers in parallel. So it's fast, I can use all of the data, I can use all the CPU cycles, RAM and disk on those machines, and if one of them dies, it's no big deal. If you can remember MapReduce to process, HDFS to store, that's the foundation you need. All this other stuff, don't worry about it. And it's changing anyway. This diagram, in fact, is already out of date. Let's pause for a second. Questions on Hadoop. Because, like I said, this is the most lightning fast Hadoop intro you're going to get. Big data intro. I'm telling you, Hadoop, HDFS, Hadoop Distributed File System to store data, MapReduce to process it.
Is there an arbitrary lines of SQL or like similar that would be the separation between data and big data beyond the distributed software thing?
That's a great question, and I'll probably kick this one over to David if I start to falter. Hey, welcome guys. Please grab a seat. There are more chairs in the back if there aren't. So just to repeat the question, if I understood it correctly, is there a length? How does one decide when I've crossed into the big data land? And if it's not terabytes or petabytes, if it's not an actual file size, could it be lines of SQL or the amount of
some kind of how many bytes essentially? Yeah.
Yeah. There isn't, and part of the reason for that is you can essentially, I'd say almost always go to IBM or go to Oracle and buy a really big relational database server. So a traditional database would run on, and you can give them as much money as you have, and they'll give you a really big machine. You can throw your data in there and you can process it. There are a lot of advantages to using Hadoop that the relational database system won't have, but there are also a lot of disadvantages. But size isn't really the trade-off there. What your manager is getting is going to be at least upfront cost. It's going to be much cheaper to string together a Hadoop cluster, but it's also going to be much more difficult to do certain types of tasks. This could be a good segue to describe kind of, so when would I want to use Hadoop versus when would I want to stick with a relational database? And if you're doing something like in maybe a typical web application where you need to go pick out individual records, I want to return one record from a table, this is really bad. And nobody talks about that. So it's kind of a problem, right? So this MapReduce paradigm is really great when you want to crunch all of the data in your cluster. I want to go across every record that I have. Think of like some kind of where all my analytics people are, right? Some kind of algorithm that's going to run across every piece of data you have. But if I have just this is my Tinder app and I want to go pull out an individual record when a user logs in, Hadoop is a really awful way to do that. It says batch processing and it's going to be slow. It's going to be really slow. So when people talk about like, well, we're in the age of big data, it's like it's taking over. Hadoop's taking over. Like it's still got a long way to go. For most like business application tasks, for my analysts, the people doing reporting, this is going to be slow and it's going to be hard. We'll get into that a little bit more later. I'm saving some for like the true or false, but it's a difficult way to process data if you want to do things like a select star where customer age is greater than 20 and their state is Virginia. It's a really, really bad way to do it. Very slow. Yeah, and for people who just joined, I'm sorry, you got basically like the shortest intro to Hadoop I could manage, and we're gonna switch over to cloud now, and then we're gonna do a little true false and try to catch everybody up with some questions that hopefully will be fun. Oh, and there's a little bit extra. So I told you two things. If you all you need to remember from Hadoop: HDFS to store data, MapReduce to process it. One more. The cool kids now don't process data with MapReduce. They use Spark. So, oddly named. It was like one was MapReduce that at least sounds kind of functional, like it could be a programming thing, like Spark. Like it makes you think maybe something can be fast or light. The deal here, in simplest terms, is the MapReduce paradigm did not use memory very efficiently. So it was a batch process that went relatively. We'll just say it was slow. Spark came along, the guys who were writing these big MapReduce jobs, they said, you know what, this is taking forever. Can we do this faster? Oh yeah, we can use memory more efficiently on all of the nodes in our cluster. Spark is the processing engine. It's the code. It doesn't look as nasty as the Java code we saw here, but it's relatively similar. It's code that allows you to run faster processing jobs, allows you to query data, crunch data faster on HDFS. For what's really fun about it, several things, but particularly you don't actually have to have your data on HDFS. So part of what you know about MapReduce, your data does need to be on HDFS. With Spark, you could have data on, like let's say in the cloud on S3 or locally anywhere, and you can connect to it. You can connect to it. We should point that out. You can connect to it and you can read from it. One kind of bugaboo I have, you'll often hear, and this may come up later in a slide, which is why I'm thinking about it, but you'll often hear the marketers say, big data or Hadoop, put all your data in one place. Or now it's Spark, put all your data in one place and crunch it. I was an English major. Anyone want to tell me if that's a grammatically correct sentence? Like, I'm not totally sure, but I don't think it is, right? I think it's missing a subject, right? So who's going to put all the data in one place? They don't tell you that, right? They're not. The implication is that they're going to do it for you, right? Buy my software, put all your data in one place, right? Hadoop. That's what's going to happen. You have to put it there. You have to do it. And that means code. That's what it means. And by the way, Hadoop distribute, I keep saying it, right? Store data in HDFS, process it with MapReduce. I didn't mention how you load data into Hadoop, into your big data system, right? Nobody does. And it's really hard. And it's a lot of code. It's difficult. Software will not help you do that. There's nothing about Hadoop, nothing about Spark that's going to help you get big data into a cluster. And no one who gives you a demo VM like IBM does or like Cloudera does or Hortonworks is going to give you more than a little bit. And you're going to say, great, I can do all these cool things. Now how do I get the data? Oh, you got to figure that out. Like, I'm sorry. We don't know. So when they show you charts like this, and I'll just hammer this home a little bit more, you guys probably it's too small to see, but this is supposed to show the flow of data coming into a cluster. It's one of those nice marketing diagrams. I'm not sure where I even got it from. But it's like XML, CSV, SQL, JSON, binary, all this data coming in. What they're not showing you, and they should be, are the people who have to write the code to move that data into the system.
But just one step, create map.
Yeah, exactly. Thank you, David. Yeah. It's very, very difficult. In teams, lots of people are going to end up doing this. And it's kind of totally missing from the conversation. So this is my manager. I screamed to them, right? Like, hey, guys, who's going to do that? Like, you? Oh, big data is going to solve the problem. Like, well, maybe, but it's also going to involve a lot of people. So not that you would necessarily get around that issue with a big relational database system, but you probably have people who are more comfortable using that technology than Hadoop. And that's not really the point I wanted to end on. Does anyone have any questions about Spark? Because I don't have a ton to put up here. There's a kind of a common performance benchmark you'll hear about Spark. There's a 1 terabyte sort competition that I think occurs on an annual basis for people who are like absurdly nerdy, I guess. And companies will put teams together to see how fast they can do this. And the previous record for a terabyte sort was held by this group at Yahoo using a Hadoop MapReduce cluster, and they did a terabyte. Terabyte is it petabyte? I can't remember. They did it in an hour with 100 nodes, and so they had a custom bare metal configurations. They assembled everything just like they wanted it, and then this team at UC Berkeley came along, the guys who invented Spark, and they used AWS, so they used the cloud, meaning they had to push their data up to the cloud, and they weren't using bare metal servers that they controlled, and they were able to process that same amount of data in 20 minutes. And even more fun, they used like a tenth of the hardware. So, yeah, it just blew it away. So you can imagine, right, the reaction from the developer community at this point, like, whatever it was, a third of the time, a tenth of the hardware, they're freaking out. This is amazing performance. Like, Spark is going to change the world. The marketers, the sales people get a hold of that, and they're just, boom, they're pushing it out there. Spark, oh my goodness, it's going to be amazing. Well, hey, just remember, you want to sort all this data, you want to process it, you're going to be still writing code, it doesn't change that, and you still have to get your data into the cluster. None of that has changed. Yes?
So what's the underlying data structure for Spark if it's not HDFS?
Excellent question. So it can be HDFS, and in this case, there's this concept of YARN, which stands for yet another resource manager, something like that. You don't need to know what this means. Beyond, there was this previously Hadoop 1.0. If you wanted to process data on HDFS, you had to use MapReduce. All of this stuff, all these other ways of touching it that you may hear about if you read up on it, Pig, Hive, etc. But all basically were running MapReduce under the scenes, under the covers. Spark sits here, so it can, at this level, next to MapReduce, and it can read data from HDFS or it could read it from somewhere else. But presumably, and I would ask as an open question, I don't know of anybody who would be storing tremendously large amounts of data that wouldn't be using HDFS. At least you want the fault tolerance, I would think. But I've heard, like through the grapevine, that a lot of startups are kind of eschewing HDFS to use S3 instead. I don't know, maybe it's because they're cooler. And we'll talk about what S3 is. That's a cloud service. Any other questions so far? All right, so super broad again. So what is the cloud? Man, I might hate this term even, or dislike this even more than big data. Anyone want to guess? We can all just go home after this. So is it this? What the hell is this? Right? I mean, seriously. Is this a joke? I mean, there's like a shopping cart in there and like news. And then I don't even know one, there's like a genome sequence.
Well, the ET hand is what gets it, I think. That's what you need for the
Great point. Yeah, it's like, wow. Or is it like, what's his name, reaching to touch his finger with God? Yeah. 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 Is it this? Like, these are some kind of cool lights on a server. I don't know. Server rack, why people do that. So I think this is the cloud when you're paying to use someone else's computers. So if this sounds like a really bare definition, I think that's what it is. Right? So cloud gets used even more inappropriate than big data. Computers can do lots of cool things that people make them do. With the cloud, you just use somebody else's, not your own. That's it. Hey, thanks so much for coming out, guys. It's been a blast. But this is it. So everything you hear around, and the executives, at least that I know, love to say, oh, when we go to the cloud, we're going to get this. When we go to the cloud, it's going to be this. It's going to be great. All your data in one place, blah, blah, blah. Omitting the subject of the sentence on who's going to do what. But it's even more ludicrous. Because at least Hadoop, at least MapReduce, Spark, HDFS, they give us some capabilities we didn't have. Sure, they offer some cost advantages that the business people like. But we're talking about processing data in parallel. It's faster. In certain cases, it can be helpful. But the cloud, what we're really talking about is I don't have to own the hardware anymore. I'm renting the car. I'm not buying it. But it's still a car. Nothing's really changed. So the bare minimum, we're going to talk about storing data, and we're going to talk about doing compute, crunching data, using CPU cycle for RAM. So when you talk about big cloud storage, and I'm sorry, I keep jumping back between cloud and big data. When you talk about cloud storage, we're talking about storing data on servers you do not own. Compute, RAM, CPU cycles on servers you do not own. So people are promising you more than this, and if you look at the AWS homepage, if you guys have accounts you logged in, you'll see a ton of things. There are lots of services, but most of them boil down to kind of one of these two things. We're either spinning or we're storing data to disk. That's it. Right? No application functionality, no increased performance per se, which we'll get to. So why would I do this? It goes back to this kind of variability of demand. I wish I had speaker view on this slide so I can see. Okay, so we'll get to it. So if you have a tough time anticipating how many servers you're going to need, the cloud may make sense, but it's not cheap. It's not going to make things faster, and it's not going to give you any extra application functionality. So when would this work well? So kind of the classic case is Netflix and Amazon. So for all intents and purposes, Netflix and Amazon are competitors, right? If you have Amazon Prime, right? You have a lot of the same, at least in that service area, these two go head to head, competing for our business. Although I think we pay for both, so maybe not. But Netflix uses strictly Amazon's hardware, AWS, Amazon Web Services, the cloud offering that Amazon has, the biggest kind of cloud company. They run all of their stuff on AWS. So why would they do that? Well, I think to answer that, we'll go back to how Amazon started offering cloud services to begin with. And I really should have made this a chart or brought a whiteboard, but you're going to have to imagine with me. So I'm Amazon, right? And I need to buy computers so that when people come to my site doesn't crash. That's what I need. I need computers to handle that load, right? And when do people come to my site most? Well, probably like at least here in the US, like around Christmas time, like maybe Valentine's Day, maybe not. Something I need to do. A few times a year, right? Load is really going to spike. But they can't go down, right? They need you to be able to hit the site and make your, buy stuff. They need that. So what do? They buy a ton of freaking servers, tons of servers, so that when their demand, which is normally like here, spikes up to here, they can handle it. So it's like most of the year they're like this, a couple times a year, boom, it goes way up and then it drops back down again. That's what they're doing. So now they're sitting there, right, and they're looking across their massive server farm. Probably looks something like this, maybe not without the lights. And they're noticing like, hey, wait a second, we're not using any of these for like 95% of our time. Could we do something better with this? So they started saying, hey, why don't we rent out our storage and our compute to people on a variable basis? So when we're sitting here in the middle of July and it's flat, someone else can rent our proverbial car, can use our computers, can rent them. That's what they're doing. That's what AWS is. And so Netflix came along, and originally they had built out a complete bare metal infrastructure. So they had purchased all of their servers, they had architected and coded their applications to work on their hardware. They noticed that their service was getting really popular. Does anyone remember when Netflix actually sent you a DVD? Right, this was a new thing for them, right? That they went with this streaming model. So they built it all out, and it was cutthroat, and they were trying to make it happen, and it got really popular, and they were having a really tough time keeping up. So they went through this extremely painful task of moving from our existing application running on bare metal on our servers to going with Amazon. For them, it was worth it. They couldn't forecast demand well enough that they had to make this change, in their opinion. And when they talk about it, because they wrote this really popular blog post that people love to pass around, I think it was even featured in Harvard Business Review, to say, oh, this is the beginning of the cloud, right? Everyone's like, Netflix is on the cloud, they're working with a competitor, oh my goodness, this is such a 21st century paradigm, I'm so blown away, we all have to go to the cloud right now. But if you read what they wrote about it, they say, this has been a Herculean effort by our engineering teams, this is of going to the cloud, of ring architecture, quick learning, nimble coding, again, incredible effort, and can-do attitude. So this part gets missed. It's like, oh my goodness, we can go to the cloud and it's going to be great for us. Herculean effort by an engineering team. Re-architecture. They had to rewrite all of their applications. There is nothing about the cloud that is going to allow your application to scale. People love to talk about how when I go to the cloud, it's going to enable me to scale, right? What's the idea behind that? Well, if I build a web application, I'm running it on my laptop, and it's my Tinder clone, it gets super popular. I get enough visitors, like maybe all of you guys, and then, oh man, I can't use my computer anymore, right? I need another one. So I run out to the store, I quickly buy one, I plug it in. Okay, I try to create some kind of load balancing setup so that I can share traffic between the two. I have to keep doing that as it gets more and more popular. So the kind of common marketing premise is, well, stop doing all of that. Just go to the cloud. They'll take care of that for you, right? The answer is no, they won't. Right? They'll give you the ability to write your application such that it can take advantage of this cloud architecture, but it will not change the way your application functions. If your application is not able to explode over a bunch of other computers, it won't happen for you. So this is what they were talking about. This is re-architecture. It gets passed over. It's like, oh, I think people think of architecture like there's some like blueprints and maybe a back of the napkin sketch, and it's like just going to do it that way. Like, no. They're writing tons of code. And just in case you missed it, it was a Herculean effort and an incredible effort, right? And can-do attitude. By a Silicon Valley startup that is like going to die if they can't get their product out, right? And now here in DC with government, we're pushing to the cloud. And do we have Herculean effort and can-do attitude? You know, I mean, it's kind of crazy, right? We have this like do or die. You know, I don't know, right?
Make America great again.
You have to re-engineer everything for the cloud. So if you hear people talking about, oh, we're going to go to the cloud. Okay, who's going to do all of the work that necessitates doing it, and is it worth it? Okay, so when does this not work well? If I haven't beaten this down enough, there's another key misconception, which is when I go to the cloud, I'm going to get guaranteed performance. But they're not actually promising you that. It's like, I'm going to go to the cloud and my application is going to work super fast. I'm going to have no problems running my code, my web app, everything is going to fly. That's not actually the case at all. They're promising availability, which means my website will not crash, presumably. That's what they're promising you. They're not promising you that it's going to run really well. Why is that? Well, I'm sharing computers with other people, right? So Amazon's flatlining now in July. I'm renting computer space from them. Well, guess what? So is somebody else. So are a bunch of other people. I have no idea who's running code, whose applications are running on the computers I'm using. I don't know. It's virtualized. It's away from me. Not that you can't virtualize on bare metal that you own, but the point being, you don't have control over what's happening on the computer you're running on. You also don't have that many options about what types of computers you actually are going to be running your code on anyway. So they give you a few options, but it isn't as customizable as you would like. At least as people who want extreme performance on their web applications would want. So what this means is, if all of a sudden a bunch of people are on your same rack are their web apps are getting hit hard too, your performance can decrease drastically. And when they start adding nodes, when your application starts to scale, there's no guarantee that you're going to get fast servers. There's no guarantee that you're going to get hardware that actually works well with your application. And I don't know the details about how to write code that runs well in different architectures or that takes full advantage of hardware, but a lot of people do, and they're not getting it from AWS. So what we're seeing now is a lot of smaller companies who are saying, I started on the cloud because we were funding this operation with my credit card, and I didn't want to pay for servers. But I've quickly realized that I wrote this awesome C code to get things to run fast, and it's not running fast because I can't control what kind of hardware I'm getting. I can't control what my neighbor is doing on the machines I'm running code on. I'm going to go ahead and buy some computers, and I'm going to run on bare metal within my organization. So I think at the highest level, we can think of the cloud in a way. Someone else's computer is like a rental car company. So if you've used Car2Go, like they're available, they're out there, but performance is no guarantee. So it's not going to go fast. Any questions so far? Time for some true or false? You guys up for this? Okay. All right. True or false? Big data equals cloud computing, and you have to shout these answers out. False. Why? Okay. So there's nothing inherent or required if you're just big data equal cloud computing? No. If I have if I'm running Hadoop, I'm probably going to run it on a bare metal cluster I have. You certainly can run Hadoop in the cloud. Amazon has a service called EC2, Elastic Compute. And they also have a service called Elastic MapReduce. You heard that MapReduce term before. I think it's Elastic MapReduce, EMR. So they're giving you a way of running MapReduce jobs on the cloud. They're going to give you a way of provisioning servers so that you can install HDFS. You can install HDFS, store your data, and crunch it. This works well for certain cases. A great example, the New York Times. And I'll butcher this slightly, and I know Dave knows it really well. But the New York Times wanted to digitize all of their historical, I guess they have newspapers, right? That's their deal? Yeah. I don't know. And they needed a tremendous amount of computing power to go through this process, right, to digitize all of these newspapers. But they didn't want to have to buy all these computers. They didn't need them afterwards. Who goes to the New York Times website anyway? They just needed it for this one job. So they went to Amazon, they spun up this massive cluster, they ran this huge process through it, and then afterwards they shut it down. So they rented a really nice car or a bunch of really nice cars for a short period of time and they got rid of them. They didn't need it after that. That was a great way to do Hadoop in the cloud. But otherwise, you're probably, if you're hearing stuff like, oh, we're going to go to the cloud, we're going to get big data, two totally different things, and probably not something that makes sense if you're actually going to be doing Hadoop. If you're going to be processing big data, if this is now part of your organization, this is part of how we do business, then you're probably going to want your own cluster. Okay, true or false? If I go to the cloud, all of my data will be in one place. False. Why is that false?
Because servers could be all anywhere in the world.
Okay, that was one good answer. What was the one from the back?
You don't know where it is.
Okay, you don't know where it
It's
is.
spread out in that in the providing organizations, enterprises can be everywhere.
Okay. Now let's say I'm a big organization like, I don't know, a U.S. government agency. Do you know where your servers are?
Yes.
Okay. Do you?
Yes.
So if your data, how about this? Maybe I'll rephrase it. If I know where my data is physically located,
You don't know which machine it's on, but you know where it's located.
I'm at too low level of an abstraction. I'm sorry. I appreciate you guys pointing this out. So I've muddled this point. When I hear someone tell me that if I use your software, I'm going to have all of my data in one place, I don't think as much about physically where it is, but I think when I'm on my file system and I'm looking at it, or I can have one access point through a shell, or I can say, I know where to go to this database to get everything that I want, or I can go to this file directory and get everything that I want.
Okay.
That's kind of what I'm talking about.
Well, in the sharing model, you can have two computers, two servers having the same file because it's in the sharing network.
Yeah, absolutely. And this is something, I guess, so I've really butchered this one.
Because it's really it's in three places. So what my data.
That's true. Well,
I'll just answer not automatically.
right. What I was trying to get to here was whether or not your data is in one place is going to be a combination of like, well, where have your programmers actually, where have they ETL'd it to, where have they pushed it to, but also what governance policies do you have on your data? Like who do you allow to see what? What have you decided? And what I see a lot are these massive share drives where data is locked down in these different places and it's access controlled here, and maybe it should be, right? Maybe everyone shouldn't have access to it, but it actually kind of is in one place, or it's in this place, and it's in that place, and it's this place. And then they're like, I hear, oh, we're going to go to the cloud, and all my data will be in one place, but no one's talked about, well, who's going to have access to what? What directories are it going to sit in? Is it going to be on the exact same share drive in the cloud now that I don't have access to this? I don't know where that is. Is someone going to go through and catalog it? Is someone going to go through and standardize all of this data? If I have some stuff in JSON, if I have some stuff in XML, text files, is anyone bringing this together? Like, no, all of those questions remain before you, right? The cloud has absolutely nothing to do with that. The real question is, right, if I'm using someone else's server, will all my data be in one place? Is that any different from if I'm using my servers? Will all my data be in one place? I don't know. You got to figure it out, right? That's what I was kind of hoping to get at here with false. So by using other people's servers, I still have to decide how my data is organized and who has access to it. So the same thing goes for Hadoop. There's nothing about Hadoop that, oh, okay, great, I've got Hadoop. I throw data into it. Love that you hear that kind of metaphor. Like I'm just chucking it in. It's super easy, and now it's there and it's available to everyone. No, not true. You still have to make all the same decisions you would if you're using your boring share drive right now. None of that would change. Ooh, true or false? I can manipulate big data in Hadoop without coding.
Well, if somebody else writes the code, that's true.
Pause here. Any other thoughts?
You did say this was from a managerial perspective, right?
Oh, absolutely.
So this would be true then.
Okay. So I still say it's false. and the reason why is something we haven't gotten into as clearly as we should have, which is when I think of manipulating data without coding, I think first and foremost Excel, right? My go-to always start with Excel, right? And when I analyze data in Excel, I'm analyzing a spreadsheet, which means rows and columns, right? If I'm going to use a cooler BI tool like Tableau, I still want data to be in this tabular structure. This works great if I have one of those relational databases. It's relatively that's even the wrong word to use. It's easier to plug one of those in and use them with Tableau. I won't do a survey, but I would ask like how many people have Tableau or like the IBM Cognos sitting on top of multiple relational databases that they know about as a non-coding language. Like, I would posit that doesn't actually happen all that much, even though it really should, because it technically isn't much of a challenge. As much of a challenge. But there's this big problem with Hadoop, and that's relational databases, the SQL servers, the oracles, the access, anything that's this kind of tabular view does not work with Hadoop. People will tell you that it does, and I know this sounds terrible, but I think they're essentially lying to you. It doesn't work. They have not yet figured out how to put a relational database on top of Hadoop in a way that's fault tolerant. And Dave, you want to chime in with some clarification there?
No, I think it's pretty accurate. So MapReduce was a limiting factor. MapReduce writes to disk, reads from disk a lot. Disk is slow. So if you're trying to do any sort of complicated query with multiple joins, you're writing and reading from disk all the time, and it doesn't work.
The other thing we haven't talked about, thank you, Dave.
Yeah.
The other thing we haven't talked about is the different types of file types. The multiple file types. So this goes back to another kind of marketing slogan, which is like, we talked about putting all of your data in one place, but also all these different types of data. So I think I have some examples to show you, but what do we mean by that? Like, okay, I've thrown out some terms that I haven't defined. Like text files, I think we kind of know what text files look like, right? But principally what that doesn't look like is a spreadsheet. It's not going to be rows and columns, right? It could just be text and text and text. How do you store that in a way that you can actually retrieve information from? If I'm an Excel user, I am utterly befuddled by a text file. I could be essentially sunk depending on how it's structured, right? I don't have an easy way in Excel of looping through paragraphs to extract information that I want. Sure, there are text functions, but it's still kind of a challenging thing. JSON, XML, these are kind of the data formats of the web. XML, I think it's fair to say, I would ask, is kind of going away. JSON is our
I hope so.
Our de facto standard. What do these things look like? I think I have an example. Yes. So don't steal my password or this is for the Watson API. So that's another thing.
Is this real? Cause
no.
okay.
I didn't have to put my credit card down, so if you want to run up the processing on IBM, I don't care. But if you're not familiar with JSON, this is what JSON is. It's a data structure. And look at this. You don't put this in Excel. Is this going to work in a relational structure in a table? No, right? Like now, I should caveat that because the last time I gave this example, there was a guy from technical guy from MapR who was like, actually, if you use this command line tool, we can read in your JSON structure and give you back a table. I think it was called like JQ something. It was like totally true, man. But by the way, a command line tool is probably not something you're going to be using if you're listening to my presentation. But there are all actual ways of doing this. Spark, as just an FYI, is pretty good at reading in JSON structures. Where this gets really, really /helpful for a web developer and nasty for an analyst is that these structures can get really nested. So this one is a relatively flat JSON structure, but each of these outer objects can contain many objects, or I think arrays, would that be the right word?
Yeah.
And so it can go as deep, and by deep I mean like this way and all the way down. There's nothing preventing it. And it's really difficult to flatten that into a Tableau without writing some code. The good news is, if you're interested, and this is where I get back to like, can you do this stuff and not code? I don't know how you go from this to Excel or to Tableau without a little bit of code. But you only need a little bit. You really only need a few lines. It's very doable. Like this would be the kind of programming task that if I were to think of the lazy person, kind of from our origin story at the beginning, this would be flattening this out, or so taking each of these things and making them column headers. That could be the kind of task that even somebody like me might get behind. Second thing, NoSQL. Raise your hand if you've heard of the NoSQL database. Okay, excellent. So the marketing on this stuff is really good, and man, is it misleading. So why NoSQL databases? What does that mean? NoSQL for not SQL or not only SQL or something like that. What we mean, what they tell you is flexible schema, right? You're not going to be constrained by these columns with fixed data types. Put whatever you want into it. It's totally open and free. It's this great thing. And it'll be fast for really specific queries that we're not going to talk about now, right? This is what they're telling you. It's flexible, and guess what? It scales across your whole cluster. That's really what it is. That's why they exist. I can't scale my relational database. If I could, I would have. Or if they could, they would have. They had to come up with a different database. Now by the database, why do we even use a database, right? Why do we use a database? Well, one big reason, I log into my Tinder app, I want my profile returned to me, so I'm doing this one record retrieval. My app's super popular, I've got billions of records. So I gotta go get one record out of a billion. Well, I could go to a file system, like on Windows or OS X. I could navigate to my directory structure, I could look through the file, I could find this file that has maybe 50 or so people in it, and I could grab my info and return it, right? That would take forever. My app wouldn't load, no one would use it. Instead, I want to be able to go really fast and get that record and bring it back. So I use database for that. That's the reason for the database. But I need this database to scale across my cluster. In order to do that, they came up with this kind of cleverly titled NoSQL, like SQL is some kind of enemy or a tough thing to use, which if you haven't done any SQL, it's going to be, dare I say, a lot friendlier than this. But when we think of a relational table, rows and columns. This is not rows and columns. I want to point out really quickly, this is a sample from the only Hadoop project with a decent name called HBase, which is I think kind of the canonical NoSQL database for Hadoop. The H stands for Hadoop. So I gave you HDFS, Hadoop Distributed File System, MapReduce for processing data, Spark for processing it faster, HBase, Hadoop database, for storing data if you need it for an application. So if I need to retrieve individual records, I'm going to use something like HBase, Hadoop database. Why? Because it scales. Is it fun to get data out of this thing? No. And why? What makes relational databases fast, or one of the things that make relational databases fast? They have indexes. I index lots of columns so I can get to data quickly. With this database, I have one index. My index is my row key. For people who've done anything with Access, have you ever even seen a row key, or let alone a relational database system? No, I don't do that. I mean, it doesn't matter. I'm going to say something like select star from my employees table and join it with my compensation table where compensation is greater than $130,000, and I'm going to fire these people, right? That would be a kind of query I would write. Join these tables. I join on the row keys, but or my primary key, excuse me. I don't know what it is. I don't care. I just tell it, give me these fields back. With NoSQL databases, we care about the row. The row is actually the only thing that matters. Confusingly, we still have values, but really, the access pattern, what I mean is how I retrieve data, is all about the row. So I have to put the data, essentially, that I want back in my row key. And I want that to sound horrible and confusing. If that kind of grates at you a little bit, I think that's good. This is weird. It's really weird. The data I want is in my row key. Like, what the hell? So when the marketer's like, oh, well, flexible schema, put whatever you want into it. Wait a second. You just told me that the data I want has to be in the row key. That doesn't jive at all. I don't think it does. So you can definitely update these things. You can do them in different ways. But what I mean is, I'm sorry, that was really inexact. What I mean is, I can put anything over here in my values section. I can have strings, numbers, XML, JSON, whatever I want. I can change it so I can say, hey, this is my essentially column A for row 1, maybe row 2. If I'm in a relational database, it has to have a column A. This one doesn't. I don't care, right? Super flexible on this side of the screen. You have to be very specific over here. And if I want to get data out of here, which in a not snail's pace, the data I want has to be in my row. This is kind of, I think, a colossal, fraud's too strong of a word, but very misleading. Very, very misleading.
It's very fashionable.
Sure. So let's take my Tinder app, right? If I'm going to access, if I have to decide from the beginning when I'm building my application now, how I want to retrieve records on, let's say, on login. And let's say I want to do it on username. So I need to put, if I'm in my SQL table, I might have a table of users, and my primary key is whatever it is, and I'll do a select statement and say I want to select your username. Where username equals, I already forgot your name. I'm sorry, but throw it in. That's my query, right? With this NoSQL pattern, I have to say I'm going to do a get in HBase, and I'm going to get a record with a filter that's going to say your username is in my row key somewhere. So I'm going to have some numbers that allow it to increment. So it's going to be like Gus 1, 2, 3, John 2, 3, 4. So I have this index, and then I'm going to say get a record that starts with like G and ends with GUS. And it's going to go down and find this record and return it. It actually works pretty well for that specific use case. Where I have a problem, and where I think like the manager should have a problem, is if I'm an analyst and I'm not the application developer who's returning exactly what they wanted and what they decided they wanted at the beginning. If I want something else, if I want anything that's in these values over here, any of this data, this is now really hard to get. Because I have to if I want it quickly, I have to tell it what's in here. I may not know, right? What if I want to get data from customers who are, let's say one of these columns is, instead of A, it stands for age, right? I want every customer who's over 17. Well, in SQL, it's really easy query. Select star from where customer age is greater than 17. Here, I have a really tough time doing that. I'm going to have to read in basically this entire table, which, since it's no SQL database, it's on Hadoop, it's big, Hadoop equals big data. There's a lot of freaking records in here. I'm going to read this whole thing in, and then do a filter, or then do a join on whatever data set I'm comparing it to.
So if it's not in the key, you're doing a full table scan every time.
Pretty much. And there are various, essentially everything that's quick about a NoSQL database is going to be some kind of row key filter. And if you can't do a row key filter, if you have to do a column family filter, sorry, I should have told you, NoSQL, here we go in Hadoop, HBase, row key, column family, you can kind of think of that as column family as a table header of sorts. There's also a column qualifier, which confusingly is basically an extension of your table heading, your column heading if you're thinking of a regular table. You timestamp so that you know when the records are actually put in, and then the values. And this is all, so these 4 lines, if you can't see it, are all one record, and then I have 3 lines here for the next record. And you end up doing a lot of full table scans if you're an analyst and after the fact you want some of this information. So you might ask, hey, what the heck, can I just take this data out of here and put it in a relational database so I can do faster ad hoc queries? Like that would be, I think, a fair thing. This is ridiculous. I don't want to keep doing this. One kind of bright spot on the horizon is that Spark, because it uses memory more efficiently, is going to be a big help here. So it's going to basically, we're going to still have to do that initial huge read, but after we do that massive read, we're going to be able to store. We're going to be able to store data in memory and hit it interactively. So we won't have to do, as Dave described, this constant reading and writing from disk with every question. So it will speed things up, but will it be faster? Like if you guys are evaluating this from a C-suite level, like will it be faster than the relational database that anybody else will sell you? Like no, probably not. All right.
Yeah, just a real world example. So we have a database in HBase that has a few billion records, and we had put, in this case, let's say column family A. So we wanted to show people hello and world when they came in. We could grab them really quick. And then we said, oh, we want to add this new feature. We want to show column family Z value 2 as well. Well, that's, instead of being 1/10 of a second to pull that record back, 17 minutes to scan the whole table. People aren't going to wait 17 minutes for the page to load. We had to go back and redesign the entire database in order to just pull that one value back quickly.
But you get that flexible schema, man, isn't that great? Yeah.
I hate to open Pandora's box, but I'm wondering if you could touch on like GrapheneDB or Graphing databases at all, if you're familiar with them even.
Dave?
Is there a connection with Hadoop or?
Yeah, so you're starting to see some graph databases can be stored in things like HBase, and Apache has a new API, Tinkerpop, that allows you to do some...
Tinkerpop?
Yeah, Tinkerpop is the name of it. That allows you to do some abstraction of the graph in the back end. Hadoop is really good for storing graph databases, and it does allow you to query it some ways more efficiently than some of the things that you have with the challenge we talked here. But you're still, with graph databases, you're either storing edges or nodes, so you have a very constricted way you're getting at the data as well.
Okay.
But it is a very common use case for cluster computing.
Cool.
And if it's not too general, correct this, the graph database is kind of out of necessity, right? A relational tabular view of that data would not be helpful. Maybe this view, with a key value pair kind of setup, wouldn't be that helpful. Is that a kind of a fair way to put it?
it solves like a specific problem. As far as I know, I haven't really used them a whole lot, but graphing databases are used to represent data in a very specific paradigm.
Yeah, it's where so joins. If you have a sort of a traditional Tableau store, I want to say who's connected to me in two hops. You wind up doing multiple joins, which are very expensive.
Mhm.
So graph databases are designed to essentially index the connections between the nodes.
Right.
So rather than doing queries and joins, you're just following the links.
I think I have one more true false. Oh, any other questions? I'm sorry.
Can you give an example of where using a NoSQL database would make more sense rather than a relational database?
Sure. So I think the one I want you guys to all take away from this is we're doing big data. Kudu. We've got all this data. We now store it in HDFS. We're processing it with MapReduce. We now build an application on top of it. So we're going to serve this data up to some kind of end user, whatever. And I'm sorry for not having a better example of the application than like this hypothetical Tinder app. But if I want to use all of the data on my cluster on all of these computers, I don't have a choice than to use a NoSQL database. I'm essentially I'm forced into it. I cannot, unless I buy just a tremendous number of relational database servers and then move the data from HDFS to my relational databases, then I don't need it. But I'm taking the data out of HDFS to put it in there. And I think probably a good thing to point out is, and I believe it's still the case, Facebook was, all those big companies, Google, Facebook, were all the pioneers, Yahoo, this technology. They use relational databases for basically all of their, I think, initial web traffic, if you will. So they'll do their analytics on some type of Hadoop platform, but they will not be serving up pages on Facebook because they were having problems with it. They essentially rewrote a lot of code to try to get us stuff that I don't understand that well and it doesn't matter. But the point being, they think it's worthwhile to basically take the data out of HDFS to ETL it into a relational database so that they can use it in their web application. So if you can't or can't afford to, or you think you can kind of get away with this NoSQL pattern, it might be a little easier for your application developer. The point where I think it becomes less helpful or really painful is for your analyst. So for the query where you want the data here, it's going to be good. But if you want any of this, it's going to be bad. And for the most of the time, the way you architect the application, the developers put the data they want in the road. The rest of us are going to be stuck. See if we got one more true false. Okay. I guess this is maybe too easy. The cloud will give my applications more functionality and increase performance. All right, let's attack the first one. So will it give me more functionality? What changed by functionality? I mean, like, I hear we're going to go to this app. It doesn't have a good visualization, or it's kind of I don't know. I wish it could give me geographic data. We're going to go to the cloud. It's going to solve that. Like, absolutely not, right? Like, what's an application going to do? What it was coded to do. Like, if someone's engineered it to create pretty charts, or to go grab geographic data, or to extract meaning from text in like a Watson-like way, well then it will do those things. If I have my application on my servers, or I have it on someone else's servers, it doesn't change how it works. Right? It doesn't make it able to do new things. That's all about how it's been coded. Okay, and then performance. So this was the slippery one, right? Will using other people's servers give my application increased performance? And I did see a shrug there, which is probably fair. You could say, well, I had really crappy servers myself, or maybe I didn't have any. Right? I'm running my application on my laptop. Okay, in that case, yes. But for the most part, you're going to want to buy. If you want performance, you're going to want to buy your own hardware. You don't want to have to share with other people.
You'll still pay for it no matter what.
Absolutely. Yeah. And it would be really interesting if someone, especially one of these analyst types or PhDs you've got, who could do a study on the costs of cloud, of AWS in particular. It'd be really interesting to compare the actual bare metal prices versus what AWS is charging. Because what I've read just anecdotally in a few blog posts is that, like, maybe every 2 or 3 years I could buy new hardware for what I'm paying in Amazon. So if I had a kind of a schedule, if I could use this server for 3 years, I might as well keep it than go to AWS and pay a ton. That's where I think that rental car analogy kind of works. It's like, if you needed a rental car for the weekend, okay, great, yeah, pay for it. But if you needed it for, 6 months. You're like, whoa, I might as well buy one. Okay. Yeah. So your applications will function as your engineers have coded them. Yeah. You cannot control it. All right. Maybe we've already handled this. I'm sorry. I didn't realize I had this many true false. So I can store and process big data on my laptop with Tableau. Okay. So does Tableau store data? True or false? Tableau stores data.
You pay for servers. It's the software. It sits on top of your data.
Absolutely right.
But
right?
you could pay them to store it, to
yeah.
host it on their public
Sure.
web.
But right, when I'm using a tool like Tableau, and I'm sorry for just assuming that everybody's familiar with it, because I know that's totally not fair. But any of these kind of BI tools, Excel being, so does Excel store data? Right, that's a good question. Does Excel store data? No, right? We have these XLSX files that's in our file system. It's stored in our computer. Excel just reads them and then does things with it that we tell it to do. Same thing with basically every other application. At the application layer, they're not storing any data. So I think that's an important point. Mostly just because even though I'm a shareholder of Tableau and their stock has been absolutely plummeting, I still just hear way too many positive reviews. Things that they're not doing. I love their charts. Great. Like, God, eat your heart out on the charts. But they're like, oh, we're doing big data with Tableau. It's storing data. No, it's not. But it can connect, right? These applications can connect to these data sources. Why is it a problem for things like Excel and Tableau and other applications to connect to Hadoop? So we say we're going to storing and processing big data. Now let's get to the process part. Processing big data with Tableau with Excel. Why is that?
It needs to read the data,
right,
be able to analyze it.
And how is data stored in Hadoop? Is it stored in a nice relational format? Excellent. Right. So do I have a standard schema for my data? No, I don't. I have this crazy schema. I can do whatever I want. I have all these files in HDFS, or maybe I have data in this NoSQL database that was a series of key value pairs that we saw, right? Where the row key is what actually has the data. It's not indexed. Very, very difficult. If people are talking about, oh, we're gonna put Tableau or anything else on top of our data, on top of our Hadoop cluster, big data, Hadoop, top of Hadoop, we're gonna do it with one of these tools. There's a lot of engineering work that's gonna have to happen to get that data out of Hadoop and into some relational database or some other type of pseudo-relational structure. If you read up on this, you'll hear about something called Hive that sits in the Hadoop ecosystem. But it's essentially a relational data structure where you're moving data out of HDFS or out of HBase into Hive, storing it there so that something like Tableau can read it. There's a lot of work that has to happen. None of the Tableau salesmen or salespeople are going to do that for you. They're not promising you that, right? It sounds like they do, but they're not. Okay. Yeah. Okay, I have more of you. Are you guys sick of these? We can stop. I promise I think I only have one more. True. Okay. If I go to the cloud, my application will automatically scale. So we talk about scaling, right? There's these processes, load balancers. They're gonna share the load of the cluster if you have a cluster of computers. So one web server doesn't get overwhelmed, will share with another, right? You can do that on your cluster. You can do it on their cluster, but it has to be coded. Someone has to write that. Someone has to write that code. Oops. Sorry. So using other people's servers or using my own doesn't matter. Gives you the option, you have the ability to scale your application. If you are a Netflix and you have no idea how many people are going to get on TV or watch TV tonight, then you have the option, provided you code your application that way, to use all of these servers that Amazon has for you. You maybe more than you actually could possibly own yourself. You could store yourself. But it doesn't mean that it's going to do it by itself. It doesn't mean that your cloud, other people's servers will solve that problem for you. Okay. Whew. Man, lots of talk. We can do it quick. So we've gone an hour and 15 minutes. Pause for question. Any other questions? People want to leave, throw things. Yeah, please.
I sort of have like an open question for everybody if you work in policy and whatnot. So if you store, let's say I work for a hospital system and I want to purchase a cloud system because the EHR, electronic health records, department now, they actually, the next stage, we have to push all of them into the cloud to be compliant with the policy. So when I have my data stored in your cloud, who is going to own it? As a settlement, if you can come up with like a solution.
So typically the data is owned by not the cloud services provider, but whoever pushed it there. And actually for health records, a lot of them are now HIPAA compliant.
Yeah.
So they will, I think in those cases,
the rankings got so high to the point they probably had no infrastructure to store it locally.
I wonder how many servers they could buy in 5 years.
There's so much records, and they've been practiced for like 35 years. So,
You can sell them some servers, you know their names?
but it's one of the reasons it was putting on the table not was privacy, because you have these regulations of your clients, you cannot just when they're not sure what they're gonna do or like how the data is gonna be stored and their privacy policies, they're not gonna make a purchase. So I just wonder, my question is, as as an analyst, what do you think is the next step in terms of privacy for the cloud?
Right, I just don't get why they would use it.
Yeah, just to store files.
Well, or anything, right? So presumably they're going to. This is part of a broader. You go to the doctor's office, they're going to pull up your record, right?
Dark doesn't make sense. You have to be able to share amongst
Well,
doctors.
But these are the other. I think these are the same electronic health records that they're now trying to put on other people's servers, right? I mean, what do you think, Dave? Like, can this make sense if I can't share? If I have to make it my own bare metal, but now I just don't own it? How cheap would it have to just be cheap enough where it's?
Yeah, actually, one of the good uses from some cloud data providers is data you don't touch very much, because often you only pay for in and out. You don't actually pay for the storage where the bits live. So if it's something that you're going to put there and not read much, some cloud providers have tiers that work very well for that. You would have to trust the provider, whoever's providing the infrastructure, that whatever policies they put in place was count on. We also are increasingly seeing things where people are putting pretty strict access controls on top of data. So at the row level or even at the cell level, you could say you have to be, for example, the health record, maybe you have to be a doctor to query this. If you're a business analyst, you can't see this personal information about the actual malady, but you can see the billing information that's associated with that record. So the people are putting policy on top of it, and then on top of a separate layer of policy policy in terms of how to query the data, and then on top of a separate policy for how the data is actually stored in the cloud.
Structure.
Yeah.
But yeah, it's a really good, tough question.
Yeah.
So if we'll shift quickly to do our hopefully fast demo. So how many people have AWS accounts? A couple, right? So you might recognize it. For those other who don't, the cloud, right? I should have put this up as my picture. What is the cloud? This is Amazon Web Services. This is the cloud. This is what it looks like. Hot mess of icons, right? Look at it. Does this look like? I want to go. Sorry, I have to go back to this thing. I mean, yeah, right. Is this it? Look at it. It looks so great. There's this cloud thing and this airplane thing. And, oh, I got this now. Crap, I have to do something. Okay, so what did we talk about? What were the two things we're going to use cloud for? What are we going to use other people's servers for? Heck yeah, you guessed the best. All right. So up at the top, you can kind of see it. It says compute. So there's EC2, which stands for like Elastic Compute. But these services are all about compute. And there's one that's pretty new. That's kind of cool. You might want to read up on called Lambda, which is going to process with the other services, with everything above Lambda. And I think that's a math term, which is I don't know what it means. With everything above Lambda, when I say I'm compute, I mean I have now said this server, this compute power is now mine. So when my web application is on or I provision it, it's spinning. If I'm crunching data, I'm getting charged for it. If I'm not crunching data, I'm getting charged for it, right? I have it. It's running 24/7. Well, in a way, that's kind of like our own little mini version of Amazon's, hey, we're flatlining here in July, but we need infrastructure to spike, right? Similarly, I provision this cloud, this compute. Well, maybe I don't need it at 2 a.m., right? Nothing's really happening. So they have this new service, Lambda, which is really, I think is, again, new. But the idea is I want to just use the compute resources I need when something happens, when an event occurs. So when someone logs in, then I want the CPU to spin. But until then, I don't. So that's kind of interesting. That's kind of cool. We're not demoing that. I don't have a good example. What we are going to demo though is storage. So David mentioned, hey, what if you store data and you want to basically set it and forget it? Amazon has an option for that. It's called Glacier, archive storage in the cloud. I guess Glacier kind of makes sense. But the big one that most people use is S3. I don't know what the third S stands for. It's like scalable storage, and they kind of fool me with the third S. But this is just a file system on someone else's server. S3, file system on someone else's server. You can store data here. Kind of fun though, we can also, just like for giggles, we can host static websites. So what do I mean by static? I mean a website that doesn't have a server running. So like when, just kind of confusing, it's a little weird, right? Like what not an application, wouldn't have application functionality. So I don't really know when I would want to do that, except for something like maybe these slides, which are written in HTML. And it's just this. This is what we were looking at. There's that nasty MapReduce Java code we saw earlier. This I can host on S3 and share with you guys. So I'm going to create a bucket region. Hopefully I don't screw this up. I can't have capital letters. I think that's weird, but what do we call this? Big data cloud. I hope I'm not getting clocked on this. So create a new bucket. Bucket is just like a directory. So it's just like if I were here, just have works, this is directory of bucket. Okay, oops. Do that. I'm going to come over here to properties. Oh, I'm sorry. Why don't maybe we can put some data into it. Upload. And now I'm going to drag and drop some files. So I'm going to take my and I'm going to upload it. They charge you for this. So storing data in the cloud isn't free. And I don't know what the cost is for this small amount of files, something like pennies. So I don't know if I could charge like maybe 30 or 40 cents a month. Oh, great. It's super slow uploading. Another fun thing about the cloud. This wasn't in my 5-minute timeline. Okay, this is going to take way too long. But also probably a really good example of where the cloud can be a problem, right? What's connecting me to this, to AWS right now? I mean, the interwebs, right? I am stuck using whatever bandwidth I have. Whereas if I had a line to my own server, it's going to be a lot faster. While this creeps along, I don't want to hold you guys unnecessarily, but I will show you an old presentation. So if you want to do this yourself, because this is, I think, what you care about, there's this tab here, static web hosting. So this is a different presentation, but essentially the exact same structure. And by the way, this website, all it really is this HTML file, hypertext markup language. Just like any other type of text file, the cool thing about this is your browser can read it and make things look pretty. It makes things look pretty because it uses CSS, and it can kind of make things happen because it uses this language called JavaScript, not in any way related to Java. That's a huge disappointment, I think, for me and maybe many others. But these are kind of like the languages of the web. Hypertext markup language, cascading style sheets make things look pretty. JavaScript kind of make your web page do things. All of them can run in your web browser. They do not need any server-side code, nothing here needs to run. Web browser can interpret all of this. So what you're going to do if you want to create your own, and you can create your own just by opening up a text editor, and you don't even need to use. You could actually just do this. You type in any text, and confusingly this will work, but you'll usually use tags. You'll have like an HTML tag, HTML, or a header 1 tag. I'm sorry, I'm kind of rambling here. Hello, something like that. You could just save this off. You'll upload it here, create a bucket like we did, upload it, and then under static web hosting, you'll click this button for enable web hosting, and they'll ask you for an index document. You just need to make this has to be the HTML page that you want to render. So if you just have one file, call it index HTML, whatever you want to call it, put that here. In my case, I have a bunch of these files, but the only one that actually has what the web page renders, that actually has information that I want to display, is this one. So that goes there. And then there's this really weird thing for permissions, and you're just going to have to Google this, and I was going to Google it to show you guys. But you have something called bucket policy. So you'll Google bucket policy to static web to host, or how do I static host the site? And I'll include the links to this stuff later. But you basically get this, I think, does anyone tell me what data structure this is? JSON, awesome. You get this JSON structure. You'll paste it in here, and basically all this is saying is allow the public to read this bucket. Allow anyone who accesses it to read it. Because right now, the way it's initially structured, it's like the files on my computer, only I can get to it, no one else can get to it. So once I do that, I've got my bucket policy, I've set my index HTML page. They'll now tell me, okay, you're now hosting this, and here's your endpoint. An endpoint is just another word for your URL. And you don't have any of that www stuff, but you now have a website. So I'll post a link later with this same thing, or you can see I kind of keep the same theme for my presentation. But I'll post a link later. Now you've used the cloud, right? And what did we do? We just basically rendered the exact same thing that I had on my computer, just available to everybody through this URL. That's it, right? Is it exciting and fun? No. It's silly and boring. Is it a little bit helpful in that it's now available to the wider world? Well, yeah, I think so. But it doesn't do anything that I didn't tell it to do. This presentation looks exactly the same on my computer as it does in the cloud. That's it. Any kind of questions? I know I'm giving you kind of a convoluted example because I'm showing you S3, the storage layer, but I'm using it to render a website, which would be something typically a company would use EC2, they use compute for that, but we can kind of hack it to do this. And just to give you an example of something that I think where the cloud is useful for me. When do I want to use somebody else's server? Well, when I want to host something and pay very, very, very little to do it. So you have a blog on WordPress, or you could write your blog in HTML. You could throw it on AWS and serve it up. All right, so that was one demo. Any questions? I'm sorry, I know we did this really quickly, but I'll post some information about it. Okay. Data scientist workbench. All right, I really think everybody who's interested in data should check out Data Scientist Workbench. It's a lot of fun. Particularly, why? Because I don't have to install anything to start coding. It's still in beta, so it keeps asking me to allow. Huh. That's ugly. So, if I want to write code to process data, I'm going to need some way of running that code. And the programming languages we use to write our data both give us a syntax and they'll give us an engine which to kind of run what we're doing. So the has anyone heard of the programming language Python or R? Right, so in these environments we have a python.exe file that we run, and we pass it a Python file to run something. Or for an Excel, we can run a Visual Basic for applications macro inside Excel. Excel knows how to read that. So what often happens is you spend a lot of time installing stuff on your computer. So I need this library to do this thing. What's really nice about Data Scientist Workbench is that you have all this available for you in your web browser. So you could hit this from your phone. You hit it from a tablet or Chromebook. I don't ever actually have to install anything. All right. And for Spark in particular, when you start talking about the big data technologies, it can be a real pain to install these things on your local machine. they'll often companies give you VMs, a virtual machine, which is like a computer that's software. So this computer, hardware, like I can touch it. If I want to run Hadoop on this computer, which is Windows, I would have to download a virtual machine. Code I would run inside of my computer. So like Inception, I'm going to have this Linux operating system machine running inside my computer that I'm going to interact with. I'm going to run stuff on it. I think it's unnecessarily confusing for people who are just getting started. So, solution, Data Scientist Workbench, go to your web browser, click on Notebook, and we can start running some Spark. All right. Yes, so what you're looking at here is it's something called a Jupyter notebook, or it used to be called an IPython notebook. Basically, what this is, it's a way of writing code. It's a shell that allows your code to persist. So I know that sounds kind of weird because it's like, hey, wait a second, what the heck are you talking about? Like when I use Excel, I have formulas that they're there. Like what do you mean persist? Well, like when most people write or do interactive data analysis, they'll use a shell, and by that I mean they're on the command prompt. And they'll type something like, let's say I'm using Python, and this is what my environment looks like. So stuff quickly goes away. It's kind of a pain. I have to get things back. What's nice about these notebooks is I can write text in them, like instructions, as the good people here at IBM have done, to say, hey, this is a tutorial on how to use Spark in Python. So one thing I didn't tell you was Spark has several languages that allow you to run these these distributed jobs, so process data quickly. You can write Spark in the programming language Java. You can write Spark in the programming language Scala. You can write Spark in the programming language Python, which I think I like for beginners like me. You can write it in a programming language called R. And in these notebooks, you can switch between Python and R and Spark up here. So it's really nice. You can also include text in them. So we can do things here, and I won't hold you guys too long on this, but what I just want to quickly show you is that I can run code here. All I'm doing in these 2 lines of code, and I'm sorry that they did this in there. Hide this somehow.
I think it's underneath your little
Sorry. Nice call, Dave. All right. So, yeah. So what I wanted to point out here, when I ran this line of code, and actually I'll run one more. So I'll just say, I'll delete that. Whoa. Check it out. What we did here is we imported a library called pandas. And if you've ever used Excel and you've had to do an optimization problem, you would go in and you'd install something called, I already forgot what, Solver, right? So you're like, wait, why didn't this come already installed with Excel? Well, the reason is because a lot of an external library could be kind of heavy, right? It's gonna weigh down your Excel installation. It's gonna make certain things slower, and it's gonna make your application, it's gonna make it bigger. So there are external libraries for Excel. Well, the power of programming, especially Python, but basically all programming languages, is the code that other people wrote that you could use. So pandas is one that's really helpful for doing tabular data analysis like the stuff we have here. That's point 1. Point 2 is we're doing something called reading a CSV. If you can see that, read underscore CSV. But what's interesting is the location. So if I have a file that I'm going to read in, right? If I'm going to open an Excel file on my computer, it's on my computer. Or maybe it's on a shared drive. I go over to navigate the shared drive. I open it, right? Here, what's kind of interesting, and this is not necessarily specific to Python or to any particular programming language, but this is a URL. And it's ibm.box.com / now we're starting to look at something that's like a directory, shared, static, blah, 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 .csv. So we're reading in a file that's stored, anyone want to guess where, generally speaking? On the cloud! Yeah. So we're doing big data in the cloud, right? Like now we've done it. And this would be what the market would say, oh great, you've got big data in the cloud now, right? Like, you're done. So it's no different really, right, from our perspective than reading it locally. It's this other location, right? I just kind of want to point that out. So when you hear they say, oh, it's it's on the cloud. Like, does it change anything for how I'm interacting with it? No, right? It may make it harder to get to it if I don't have an endpoint that's exposed. It may make it easier if it was something that, well, I don't think it would make it easier. It would be exactly the same. So, in this case, I just read in this file. This file is this kind of spreadsheet-looking thing, or at least it's displayed like that, thanks to this pandas library. But I got this data that looks like something I'd use in Excel, and I've used Spark to do it. I've heard Python, PySpark to do it. Actually, to be fair, I've only shown you Python so far. I haven't shown you Spark. So we'll see. We'll just scroll down and we'll take a look at some Spark. This step is unnecessarily confusing, so I'm going to skip it. And this is where I tried to run some code that didn't work, and it threw a syntax error. So, actually, I won't totally skip it. But basically, what I want you to see here is we're in this header, this section called creating Spark data frames. So it says something like, with SQL context and a loaded local data frame, we can create a Spark data frame. What we mean is we want to load our data into Spark. What we want, and by Spark, whoa, that was a mistake. We want Spark to be able to read our data, right? And so in order to do that, to get this distributed processing power, we don't really have a cluster here, but we have a pseudo one. We're going to this environment's going to allow us to pretend like we have this distributed architecture where we can run Spark. We're going to read data in, and we need to expose it in a way that Spark is able to read it. And that's through this thing called a Spark context, or in this case, the derivation is a SQL context. So that's a little weird, but this is kind of the only weirdness you need to get through. So I went from my original Python statement was read CSV. I had that up here. That kind of makes sense. Read a CSV. Okay, I can open CSV in Excel. Read CSV. To do this in Spark now, we just need to do this SQL context. Create one of these guys, and then in this case, we're going to create something called data frame, which is really just a table, and we're going to pass it the table we already created. So now we're taking our table from Python, small data, to Spark, big data processing. It's kind of a weird step, but there's just one little hop here, if that makes any sense. And now, anything we do now,
Oh boy.
that was really smooth. will be big data processing. So when I do the exact same function I did before, data frame, empty cars, head being the first 5 rows, I can now do that in Spark, the exact same thing. But now when you do this, you can update your resume and say you know how to process big data, right?
There's no code publicly available on the workbench.
Absolutely. So,
At the moment,
oh no.
it won't load. So I don't know.
Well, I promise you, I don't have a special way of getting in there. But I would encourage you guys to kind of go through these notebooks and take a look. I wanted to show you one more, if I could. If I can use this part in Python. Cloud Services Notebook. This one, I think, since we were talking about big data in cloud, I thought this was really cool of IBM to do. This is the last thing, so 5 more minutes. IBM sells a cloud offering. I think it's called Bluemix. It's built on a project called Cloud Foundry. So that competes with Amazon. So they don't want you to use AWS. They want you to use their offering. But basically, Amazon owns the market right now. So it's kind of foolish to put out. What so far I've done is said like, oh, you want to get data from the cloud? Well, go to ibm.box.com and you can get your, like we saw in the initial URL. But here they're actually going to show you how to integrate with data that's on AWS, on S3. So I really appreciate that because I think that's what people are going to be using, right? That's what I'm using to host my static site. I think that makes sense. I think that's why this is a helpful tutorial. So Dropbox, datascientistworkbench.com. And in this case, they show you how to create a bucket with code. So we created a bucket a few minutes ago, just using this interface. We came in here and said, oh, buckets, create a bucket. You can also do it with code. You'll need to register with AWS, but you can step through these instructions. Since we've already done that, this is taking you through how to load data. It's a little boring. You can do the same thing with Dropbox, so if you want to use Dropbox, similar. I just want to quickly show you Twitter, the Twitter API. I apologize, guys. Awesome. So, how many people use Twitter? You know about it, right? So, what's nice about Twitter, especially if you're a business, right? If I use Twitter, for the most part, I'm using it through my phone, right? So I'm looking at the app, blah 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 blah.
Are these real tokens?
Oh yeah, they are.
I'm not streaming. I can black it out before I upload it.
I can show my token though, right? Because that changes out every call, or that.
I don't know.
Okay, I'll scroll down. When I use this user interface through my phone, I just got a text that somebody's requesting $250 from PayPal. I don't know what that's about. Sorry. I'm using the user interface for Twitter. The API here is the application programming interface, so it's how code talks to code. So this can be nice for going to gather a bunch of tweets, right? On my phone, I can search, I can scroll. It'd be nice if I could search with code, if I could gather a lot more information. This will help you do that. And they're giving you a bunch of sample code here to get you started. So you'll need to paste in you'll need to register with Twitter. They have a quick explanation. You'll get a key, you'll get a secret. You'll paste that in. You can't look at mine because then you can steal mine and use mine. I'm sorry, but we can use this. Sorry, guys. And I can do something like get my timeline now. Hopefully that works. Okay, so here is my timeline with 4 lines of Python. So I create this thing, construct the API instance, and I say API home.timeline, and I print out the tweets that are on my home timeline. I think I can also search. So because mine is boring, I'd really like to see. Let's see if I can have an example here. Let's do a search for Trump. Let's see what's showing up. So Donald Trump determined to make New Hampshire his proving ground on Tuesday. He did. Oh, maybe that means he won the primary. I don't know. He did. Imagine if Trump wins South Carolina with Cruz and Rubio finishing 2 and 3. Then where do we go from there? Market will be a mess. This actually isn't as one major complaint. This isn't as bad as I thought it would be. Let's change it to
Racist, sexist, homophobic.
yeah. Justin Bieber to Kenyax Clifford. Yeah, what? Something in what looks like Portuguese about Justin Bieber. Man, a lot of Portuguese stuff. So you can start to play with this, right? If you want to start processing data, you want to process tweets, you have the option to do that pretty easily. It didn't take a whole lot, right? And they gave us all the code. I plugged in my key and my secret, which Twitter will give you if you register. So you now can do big data in the cloud, right? I could do Spark on a pseudo-distributed cluster, do this web application data science project. Any questions? Anyone gonna use? Well, let's see. Maybe you want to do one. Yeah, that's all I got, guys. I really appreciate you hanging in with me for an hour and 45 minutes.